A. The cumulative frequency diagram shows information about the times taken by 200 students to solve a problem. Use the cumulative frequency diagram to find an estimate for 1. The median. So we have 200 students. The median is the value in the middle. So the middle of 200 would be 50% of 200. So that's 100. So we're looking for the 100th student. So we go to the cumulative frequency at 100, draw a straight line, hit the graph at that point, and it corresponds to 34 minutes. So the median is 34 minutes. 2. The interquartile range. The interquartile range is the difference between the 75th percentile and the 25th percentile. So we need to find the 75th percentile. We have a total of 200 students. So 75% of 200 is equal to 0.75 multiplied by 200. So that's the 150th person. So we go to 150 on the cumulative frequency on the y-axis over here and do the same thing just like median. So we draw a straight line across and it touches the graph right here and it corresponds to 43 minutes. So the 75th percentile is 43 minutes. And then we do the same for the 25th percentile. So 25% of 200 is equal to 50. So we want to find the 50th student. So we go to 50 on the cumulative frequency, draw a line across and it hits the graph there. And it corresponds to 25 minutes. So the interquartile range is the difference between 43 and 25, so that's 18 minutes. 3. The number of students who took more than 40 minutes. So we go to the x-axis, which refers to minutes, and 40 on the x-axis is here. If we draw a line straight up, it hits the cumulative frequency curve here, and it corresponds to cumulative frequency of 140. This means that from 0 to 140, 140 students took less than 40 minutes. But we want to find the number of students who took more than 40 minutes. So the students who took more than 40 minutes are over here, between 140 and 200. Therefore, the number of students who took more than 40 minutes would be between 200 and 140. So that's 200 minus 140, which equals 60. So 60 students took more than 40 minutes. B. Roberto records the value of each of the coins he has at home. The table shows the results. 1. Find the range. So the range is the maximum minus the minimum value. So the maximum and the minimum. So the minimum value of the coins is 1 and the maximum value is 50. Therefore, the range is 50 minus 1, so that's 49 cents. 2. Find the mode. The mode is the most common one. So the most common coin in this case is the 20-cent coin because we have 4 of those. Right, so the mode is 20 because 20 has the highest frequency. 3. Find the median. So the median is the middle one, right? If we put all the coins in order from smallest to biggest, the median is the middle one. So first, we need to find the total number of coins. The total number of coins is the sum of the frequency. So that's 3 plus 1 plus 3 plus 2 plus 4 plus 2, which equals 15. So therefore, the middle one, if we have 15 coins, the middle one would be at 15 plus 1 divided by 2. So the middle one is at the 8th coin. So if we look at the table, the first three coins have a value of 1. So that's 1, 2, 3 over here. Another coin has a value of 2 cents. So that's 4 coins now. And another 3 coins, 1, 2, 3 over here, have a value of 5 cents. So now we are at 7 coins. So the 8th coin over here must be in this group. So the 8th coin has a value of 10 cents. Therefore, the median is 10 cents. Four, work out the total value of Roberto's coins. So the total value would be the value of each coin multiplied by the number of each coin. So for example, for the 1 cent coins, it would be 1 multiplied by 3 1-cent coins. So we need to add it to 2 cents multiplied by 1 coin, 5 cents multiplied by 3 of those coins, plus 10 cents multiplied by 2 of those coins, plus 20 cents multiplied by 4 of those coins, plus 50 cents multiplied by 2 of those coins. And that equals a total of 220 cents. 5. Work out the mean. The mean would be the total value of coins divided by the total number of coins. So we already have the total value of coins from part 4, so that's 220 cents. And the total number of coins is just the sum of the frequency. So that's 3 plus 1 plus 3 plus 2 plus 4 plus 2, which is 15. So the mean is 220 divided by 15, so that equals 14.66 and so on. So we need to round this to 3 significant figures, and to 3 significant figures, that's 14.7 cents. C. The histogram shows information about the masses of 100 boxes. Calculate an estimate of the mean. So we have to work backwards here. We can calculate the estimate of the mean if we have a table of group data. And we can always turn a table of group data into a histogram. So from this frequency density and this histogram, we can come up with a table for group data, which we can use to find the mean. So if I separate that into 3 groups, because we have 3 columns on the histogram, the first column goes from 0 to 10. So the first group of data would be between 0 and 10 kilograms. The second group, or the second column goes from 10 to 15. So the second group of data would be between 10 and 15 kilograms. And then the third group of data goes from 15 to 30. So the third group is for 15 kilograms to 30 kilograms. So those are the masses of the group. Next, we need to find the frequency of each group in order to calculate an estimate of the mean. Usually, when we create a histogram from group data, we calculate the frequency density by doing frequency of the group divided by the class width. That means that we can calculate the frequency from the frequency and the class width by doing frequency equals frequency density multiplied by class width. For the first group, the frequency density is 3. And the class width goes all the way from 0 to 10, so the width is 10 minus 0. So that's 3 multiplied by 10, so that equals 30. So the frequency of the first group is 30. We can do the same for the second group. So for the second group, the frequency density is 8, and the class width goes from 10 to 15. Therefore, the class width is 15 minus 10, that's 5. So 8 multiplied by 5 equals 40. So the frequency of the second group is 40. We can then do the same for the third group. So for the third group, the frequency density is equal to 2, and the class width goes from 15 to 30. So the class width is 30 minus 15, so that's 15. So 2 multiplied by 15 equals 30. So the frequency of the third group is equal to 30. And now that we have completed the table of values for this group data, in order to calculate the estimate of the mean, because it's a group data, we would use the midpoints of each group. So the midpoint of the first group is the middle of 0 and 10. So that's 0 plus 10 divided by 2, which is 5. The middle of the second group would be 10 plus 15 divided by 2, which is 12.5. The middle of the third group would be 15 plus 30 divided by 2, which is 22.5. And then the mean equals the total mass divided by the number of boxes. So to calculate the total mass by using the midpoint, we would do 5 multiplied by a frequency of 30 plus 12.5 multiplied by a frequency of 40 plus 22.5 multiplied by 30 divided by the total number of boxes, which is 100. And that equals 13.25. So the mean mass of the boxes is 13.25. And because the answer is exactly 13.25, we don't need to round it. We only answer to 3 significant figures when we have to round the value. For this one, it's unnecessary, so the answer is just 13.25.